Let's dive deeper into the picture-in-picture implementation in Flutter. So what exactly is picture-in-picture? This feature allows you to view my entire screen. On the Android side, you can see the video calling in picture-in-picture mode, and this is also applicable in iOS. Firstly, we have a repository set up for this implementation. Just clone it and use Flutter pub-get to get the dependencies. You will need to add your video SDK token, which can be generated from our dashboard. You can visit videosdk.lab to access it. It's recommended to generate a 7-day token for testing purposes. Copy your token and paste it here. I already have my example set up, so I won't do it again. Here, you can add your token easily. Then simply run Flutter pub-get. This will fetch all your dependencies. To see the output, you can run Flutter run, and it will look like this. Let's move to the coding part of the video. You can get a token from our Video SDK dashboard. With this token, you can make a post request to our server to obtain a meeting ID. Use this meeting ID in the meeting screen to join the Video SDK meeting. Now, let's go to the implementation of PiP. We have an architecture for PiP mode available for both iOS and Android. First, let's check Android as an example. Initially, you need to be in the meeting screen. Set the in-meeting flag to true. Next, you have two options. Either press the PiP button or background the app so that the on-PiP request trigger is activated. This check determines if the flag is in PiP mode, true or false. Based on this, you are sent into PiP mode for the meeting. And if you click the button, it will directly send your meeting to PiP mode. Now, let's talk about the iOS architecture. For the iOS implementation, there is a bit more complexity, but it can be easily integrated into the Video SDK. As you may know, iOS requires AV player frames to enter PiP mode. We use WebRTC for this purpose, so we use RTC frames instead of player frames. We then need to convert our RTC frames to CV pixel buffers, which will be used to generate a custom view. Using that view, we can send our entire meeting into PiP mode. Next, we will proceed to the code implementation. Here, we have a method channel called PiP channel to acknowledge the Android part. Let's get back to the implementation details. We handle the method called a function that gives you acknowledgement on the Android side. This sends a message confirming that the operation is done as messages are received from Flutter. Initially, we set up the method channel and send the acknowledgement part. The onMore requested gives you a Boolean value, true or false. If your app is sent to the background, it will return true. Otherwise, it will return false. The main service starts with more functionality. We check that the build version is above Android 8. We set the aspect ratio and call APIs to activate PiP mode in Flutter. Next, let's move to the iOS part. For iOS, you will need to get the frames on the native side. For this approach, we already have a video processor on our iOS implementation. You can refer to the documentation of the video processor. Simply register your processor and set a beep channel. We set various methods like start beep, stop beep, and dispose within our method channel. In frames.swift, the VIO PiP manager creates a split view that has both remote and local views. For the local view, you use the remote processor to obtain the local stream. And for the remote stream process, use the appropriate processor. Now, let's go to the iOS implementation in detail. For the iOS implementation, you need to register a processor that provides local frames. For extensive details about the video processor, refer to our documentation. Finally, you will set up a major channel to manage several cases, like setting up beep and managing remote streams. We set up methods for starting beep, stopping beep, and disposal. In our main file, frames.swift, we retrieve both the remote and local streams. We then convert the RTC frames to ABE layer frames, processing them as a single view. In this view, we've created a split view that combines both local and remote video views, allowing the use of PiP mode. You can see here how we set up PiP mode and how we start and stop it appropriately. There's one variable that can trigger PiP mode on or off based on your requirements. If set to false and the app goes into the background, PiP mode will not be activated. But if it's true, it will automatically activate PiP mode. That's all from my side. Thank you for tuning in. Please don't forget to give us some stars on GitHub. If you have any doubts, feel free to ask us on our Discord server.